understand how much of power is consumed by various kinds of equipment. Just have a look at this slide. Try to capture here various equipment we use, in our offices or partially our homes, offices, and how much power does it consume, and what's the impact on the environment. Let me just go through the few of the commonly used equipment. Just look at typical desktops. A desktop consumes between 1 or 1.5 incandescent bulb equivalent of power, and an yearly consumption is about 289 kilowatts, which translates to around about 100 plus kgs of CO2 emissions. So to absorb that amount of CO2 emissions, you need to actually grow at least a tree, minimum a tree can absorb that one. So maybe a server. So there's a difference between the server and the desktop. Servers, although you have wide variety of models, there are vendor specific, there's a commodity servers. And if you just take a simple server average, running a server, and typically servers are kept on 24/7, 365 days a year. Look at typically about 6 incandescent bulbs, 1750 kilowatt hours, 1000 kg or equal to 1000 plus kg of CO2 emissions. You also have you need to grow plenty of trees to absorb the CO2 emissions of a single server. So similarly, you look at a network switch, laser printer. So one is energy consumption and one is the total yearly energy consumption. So why do you see the difference here between a laser printer, a projector, a network switch, and a server? Typical laser printer, is not kept on all the time. Goes into a sleep mode very often. A projector itself is also not kept on. A network switch is typically kept on most of the time as a part of your IT infrastructure. Servers are kept on. Desktops are sometimes people do turn off, sometimes people do forget to turn off. Let us look at this from a different perspective. The various other equipment, electrical equipment, how much power do they consume? We use the unit of watt hour, right? 1 watt, basically if you consume 1 watt for 1 hour, it's 1 watt hour. And we see the emergence of tablets as the end computing devices today. How much power does a tablet consume? Is about 10 watt hour. So if you use a tablet for 1 hour, doing something, watching a movie or checking your emails or blogging, typically it's about 10 watt hours. That means 10 watts for 1 hour. So these numbers may vary depending on your tablet, brand, model, and make. I just taken an average number. Similarly, if you run a fan for an hour, you consume about 35 watt hours. An incandescent bulb is of 60 watt hours. A PC desktop, 80 watt hours. A LCD TV, a 32 inch is about 100 watt hour. So put in perspective, many of these home consumer equipment consume probably less than many of the significantly less power than the IT equipment. Let me go ahead and look at how much energy do you consume globally. Electrical energy, I mean the electrical part, electrical energy only. If you look at the World Bank report on the energy consumption as of 2009, so it's about a couple of years earlier, but you can as well extrapolate the growth and see how it is today. A global energy consumption in 2009 as per the World Bank report is 18,500 terawatts. Terawatt is huge, right? We have a kilowatt, 1,000 watt is a watt hour is a kilowatt hour, 1,000 kilowatt hour is 1 megawatt hour, 1,000 megawatt hour is 1 gigawatt hour, so 1,000 gigawatt hour is 1 terawatt hour. So you are saying 18,500 terawatt hour. It means you are running so much, you are consuming so much of power. And in comparison, let us look at the IT part of this, like the data centers. The data centers are basically the sites which power the servers. For example, Google has its own data center, Yahoo, Google, Facebook, LinkedIn, everybody has their own data centers, and data centers host servers, storage, other equipment for all these applications to run. So as per the latest census from the data center dynamics, the global data center power consumption is about 322 terawatt hours. It is sort of a small percentage of the global electricity consumption, but nevertheless, it's a significant part. Look at the country-wise electricity power consumption, right? What the power consumed by the data centers worldwide is enough to power the entire of Russia. Most of the Russia can be powered by the 322 terabytes of power, which is a huge number. And let us look at the other set of devices which are coming to the market today. We have seen tablets literally everywhere. So look at the estimate of tablets in the world. By 2015, there are going to be 350 million plus tablets in the world. and the total energy consumed by the tablet itself is 3 terawatt. How much is 3 terawatt? 3 terawatt hour of power. The 3 terawatt hour of power is sufficient to power 1.5 million houses or 15 lakh houses for 1 year. So although these tablets, smartphones consume a small amount of power, they are growing in huge volumes. Every house has a couple of tablets, every office has hundreds of tablets. So although individual power consumption is low, because of the sheer volumes of numbers, aggregate power consumption is very, very high. So you can talk about IT vendors, the chip manufacturers saying my chips are more efficient, more good, but again, they are becoming more powerful and they are also becoming more feature rich. We had many years back we had simple mobile phones, today we have smartphones, more functionality at the same time, consume more power. So these IT devices which are small, powerful, becoming very, very pervasive, and of course, aggregate, they consume a lot more power.